Hello and welcome to the second webinar of our Thermoscientific Upgrade Your Peptide Maps webinar series. My name is Dr. Kyle De Silva and I will be your moderator for today's session. The session will be presented by Dr. Amy Farrell and Dr. Mauro Depra. Amy is an Applications Development Team Leader at the Irish National Institute for Bioprocess Research and Training, or NIBERT. And Mauro is a Pharma and Biopharma Solutions Manager with Thermo Fisher Scientific. During this interactive presentation, we will also have a Senior Biopharma Application Scientist, Dr. Martin Samanik, here to answer all of your technical questions in the chat box and also in the Q&A panel session at the end. Over the course of this series of 4 short webinars, you will learn about the advantages of our full peptide mapping workflow. We will present advances in protein digestion, peptide separation, detection, and data processing using new tools that represent a significant upgrade to existing methodologies. Our second episode in the series today focuses on the importance of reliable and efficient separation of peptides in biopharmaceutical peptide mapping. So I would like to welcome Dr. Mauro Depra to begin the presentation.
Thank you, Kyle. I will start straight away. So in biopharmaceutical analysis, normally peptide mapping is run to check to confirm the identity of the protein or to run solid purity analysis. What happens is normally that you take your protein, you digest it normally with trypsin, and then you obtain a mixture of peptides. And then you analyze these peptides by LC-MS or LC-OV. Normally we recommend to use the Smart Digest kit for this. That would be a trypsin kit that was extensively explained in the previous webinar. So if you use a trypsin digestion and you take, for example, a monoclonal antibody, if you analyze this mixture of peptide by LC-MS, normally you will see a couple of thousand components. If you do that by LC-UV, you aim at seeing roughly 100 peaks. So now, if you have a mixture of 100 peptides, 100 peaks, what you need to have in terms of resolving power from your chromatography is a peak capacity of roughly 300. If you add 300, normally you're sure that you see sufficient resolution to properly characterize this mixture. In terms of runtime for the chromatography that you want to have, we are talking about 30, 45 minutes, preferably not longer than this. As I mentioned, the peptide mapping is run to confirm an identity of the protein or to check the purity of this protein. Either way, what you normally do is you compare a reference standard to an unknown sample. And therefore you have a comparison. And for this sort of comparison, you need to have a highly reproducible chromatography to make your life easier. So in this first slide, we'll see how to increase the resolving power and to get to this minimum of 300 peak capacity that you need for a proper peptide mapping. So you can act on 3 different parameters. One is gradient time, the other is column efficiency, and the last one is column temperature. So we know that peak capacity is a function of gradient time. It increases with gradient time, and it is higher for long and shallow gradient, as you can see in the left figure. However, we cannot invest too much time in the biopharma environment. Therefore, we are a little bit limited in changing this parameter. The other one is the column efficiency. So the peak capacity is a function of the square root of the theoretical plates of the column. Therefore, you need columns packed with small particles and possibly long columns. To show these effects, I choose a picture reprinted from a nice publication from Free University of Brussels. And here the authors were checking the performance limits at 800 bar for columns packed with 2, 3, or 5 micrometers. So basically what the authors were doing were measuring the peak capacity for this column at different column lengths. Here you see in the middle figure, you see indeed that when you increase the column length at a specific pressure, your peak capacity increases. Then when you compare a particular column length, let's say, for example, an hypothetical 1 meter column, you clearly see that the peak capacity provided by a column packed with 3 micrometer particles is much lower than the one provided by the column with 2 micrometer particles. We are talking for this specific example, 300 versus more than 500. The last parameter we can change is the column temperature. And peptide mapping benefits from high temperature, high column temperature, as you can see in the right figure. And this is due to the fact that the kinetic of the mass transfer of the peptides from mobile phase to stationary phase are optimized. Now, what can we do? What do we offer in terms of products to make sure that we achieve the proper resolution for peptide mapping? Well, firstly, we have the column. We normally recommend to use the column thermoscientific acclaimed Vanquish C18. It's not the only column available in our portfolio that is providing very good results for peptide mapping, but it is the one we tend to prefer. And the reason is that this column is available in 250 millimeter length. So as I explained you in the previous slide, length will increase plates and therefore resolution. Other features of this column, quite important for peptide mapping, is the temperature specification, which is 60 degrees. But here is 60 degrees means that you really are confident that if you use it at this temperature for long term, you will not suffer any loss of performances. Other features of this column is the small particle size. We are talking here about 2 micrometer particle size. Excellent peak shape for formic acid and TFA alike, and wide pores under 20 Armstrong. And we have a diameter of 2.1 millimeter ID, which is currently the best format for analytical methods. In terms of system for the biopharma analytical development, our system of choice is the thermoscientific Vanquish Flex UHPLC quaternary system. As the name says, is a quaternary pump system, and the pressure specification is 1,000 bar. Important feature for peptide mapping of this system are the low dispersion fluidics that allows us to fully profit of the high resolution of the column. Advanced temperature control that I will explain later in the slides later. And other features such as the smart inject, which are also described later on in the presentation. Of course, there is seamless integration of this system with any high resolution and accuracy MS from the Thermo Scientific portfolio. Here we can just have a glimpse of the performances of this solution. In the chromatogram on the top right of the slide, you can see a detailed view of 2 peptides separated by coupling, 2 acclaimed Vanquish columns together for a total length of 50 centimeter, and a 30 minutes gradient time. Please notice the exceptional peak shape, very symmetrical peaks, And also how narrow these peaks are. We are talking about 2 seconds at half height. In the bottom right panel, we see a long-term peak capacity evaluation for BS8 digest. Here we are talking about several days of continuous operation at 60 degrees. The message you can get from this figure is that the peak capacity remains unchanged after several days continuous work at 60 degrees. So I mentioned that the Vanquish Flex has advanced thermostating capabilities. Now we go a little bit more in details about that. So first of all, the column oven can operate in 2 different modes. We have the forced air and the still air mode. The capability of choosing between modes is mainly important for method transfer from and to the Vanquish Flex, but also has an impact on the performances of the separation. For example, if you see it on the left bottom figure, you will see the comparison for peak capacity at high temperature in peptide mapping, of course, between forced air thermostating and still air thermostating. We notice that with still air we achieve slightly higher peak capacity, not so much, but just something to take into consideration. Another important thermostating capability feature is the pre-column heater. What this pre-column heater does is that it prepares the mobile phase prior entering the column, so it brings the temperature of the mobile phase to the same temperature as the column before the inlet. This is a really important thing to take into consideration when running peptide mapping at high temperature, because if you don't properly preheat the mobile phase, when you increase the temperature of the experiment, you don't actually improve the peak capacity, but you will decrease it, as you can see in the figure on the top right. The pre-column heater is an active heater and is a low dispersion, so you should not fear that you lose the column resolution by implementing this extra hardware. Okay. Now, I mentioned the Vanquish Flex quaternary as is the system of choice for analytical development in biopharmaceutical analysis. If you require more performances, the other system to take into consideration is the thermoscientific Vanquish Horizon HPLC system. The main difference is compared to the Vanquish Flex system is the type of pump, which is in this case a binary pump with a low gradient delay volume which is highly suitable for LC-MS and high throughput analysis, and the 1500 bar capability, which is 22,000 psi. Why do we need all this pressure? You can see an example on the chromatogram in this slide. Here we show how we managed to scale down a 30 minutes peptide mapping experiment to a 5 minutes gradient peptide mapping experiment. So we scale down means that we shorten the gradient time, and then we have to increase the flow rate. However, this requires pressure, and in the 5 minutes experiment, we use roughly 1300 bar. And here I have the chance to talk to you about another important feature of the acclaimed Vanquish column, that in fact it can take 1300 bar and more, because the pressure specification of this column is 1500 bar, like the Vanquish system. Interestingly, in this speed-up method, we see that the sequence coverage, this was an LC-MS experiment, the sequence coverage was always 100%, also for 5 minutes gradient. And here, in this specific case, the thermoscientific QS-active HF enabled this, because it's has a very fast data acquisition, and therefore you can really process also very narrow peaks. So now we come to the first poll question, Kyle.
Yeah, so we'll have our first poll question now. The question is, what temperature do you perform your peptide mapping separations at? The answers are less than 40 centigrade, 40 to 59 centigrade, 60 or greater centigrade, or if you don't currently perform peptide mapping, please just say. So we'll just allow a few minutes for people's answers to aggregate, or a few seconds rather. Column temperature and stability is so critical in peptide separations. It's always interesting to hear what experts working in the field are working to. So we have around 60% of attendees have responded in the last few seconds. Okay, so now we can see the results. Mauro, do you have any comment here?
Yeah, I'm glad to see that the majority of users are already aware of the advantages of working at high temperature, but I still see a relevant portion of the people that still prefer to work at lower temperature. Okay, now I would go ahead with the presentation. So now we change a little bit the topic. We don't talk about capacity any longer. And now we talk about comparison of reference standard versus unknown sample. Here we see an overlay of two peptide mappings, actually mirror chromatograms. And here we have the same sample that was digested with slightly different protocols. If you see on the right side of the slide, you will see that some of the peaks are exactly matching, both in terms of peak height and retention time. Some other peaks are matching in terms of retention time, but have a different height. And some peaks are present only in one sample and not in the other. Here you just can have a feeling of how important it is to have highly reproducible chromatography for this kind of comparison. And so the thing is that when you only need to compare two chromatograms, you can easily do it like this, so just have a visual comparison. But if you need to compare more than two chromatograms, if, for example, you have, let's say, a stability study where you have multiple samples to control, injected multiple times in the system, so you can understand that the visual comparison is no longer a good choice. For this, you would need to automate your workflow, your data processing. And in the following few slides, I'd like to show you a few things you can do with our chromatography data system, which is Chromeleon 7. And at the same time, I also want to show you why retention time precision and peak area precision are really important for this kind of comparison. So let's imagine you start by processing the chromatogram from a reference standard. So what you do, you have to run an integration, the peak integration, and you can do that in automatic fashion with Chromeleon 7 by using a wizard, which is called a Cobra Peak Detection Wizard. This wizard will guide you through a few simple steps, and at the end of this, you end up with a chromatogram which is integrated, all peaks integrated. After you have run the peak integration, you need to provide each peak a name, and for that you use another wizard embedded in Chromeleon 7, and this wizard is the component table wizard. So you assign here a name, as you can see in red in the chromatogram. It can be a generic name like component 1, component 2, and so forth. Otherwise, if you have the real peak name from LC-MS experiment, if you know what each of these peptides are, you can use that name for the peak assignment. So once you have done these two exercises for the reference standard, you save your processing method, the old processing method, both integration and peak assignment, and you will use the same processing method for all the other unknown samples. So you don't have to do it manually. If we talk about the peak assignment, the peak assignment process, what Chromeleon does is that assign a window, a retention time window, and when you run an unknown sample, if the peak is falling within this retention time window, it will get the name of this particular peak. Now, on the top right chromatogram, you see an overlay of a reference standard, the black trace, and an unknown sample, which is the pink trace. In this case, the chromatography was highly reproducible, and we have here a minimum peak shift, which is roughly 0.3 seconds, and that corresponds more or less to retention time RST of 0.018%. So in this case, peak assignment for the unknown sample is very straightforward, and the Chromeleon will not do any mistake in assigning the proper name to the right peak. And you can easily, therefore, quantify, you can easily calculate the relative area of the right peak. In the bottom chromatogram, you see we artificially induce some imprecision in the method, and we induce some shift of 3.8 seconds to the peak of the pink chromatogram, so the unknown chromatogram. And here you can see that, and by the way, this corresponds to retention time precision in terms of RST of about 0.16%. Here you see that the peaks are no longer falling on the right peak assignment window. Therefore, the peaks will be wrongly assigned. If you look at the table on the right, you see that the relative area of the peaks for the unknown sample will be wrongly calculated because of the peak misassignment, and also some of the peaks will not be even detected. Okay. As you see, therefore, retention time precision is of paramount importance if you want to work to automate and to streamline the data analysis of peptide mapping. So the Vanquish flex quaternary system can deliver really good precision, and this comes from two different parts of the instrument that work synergically. One is the autosampler, and the other one is the pump. The pump has a feature which is a smart flow feature, which enables really consistent flow delivery. And the autosampler has the so-called smart inject feature. This smart inject feature is a sample pre-compression feature, and this means that the sample, after being drawn from the vial, is compressed to the same pressure as the column pressure, and then afterward injected. This is quite important for the following reason. If you take a look at the figure on the bottom left, you see the example. The top example is the pressure trace that is recorded when you don't pre-compress the sample prior to injection. You see that during injection, there is a pressure drop. This pressure drop will cause flow inconsistency, and therefore will impact the retention time precision. As you can see here, this peak is not always, for repeated injection, is not overlapping exactly. With the smart inject feature, we can pre-compress a sample. We no longer have the pressure drop visible in the pressure trace, as you can see in the pink line on the bottom left figure. And the peaks for repeated injection are always at the same retention time. So in terms of number, what does Vanquish Flex deliver? So let's take a look at both bovine serum, albumin, therapeutic digest. This injection is used in the chromatograph on the top left here. It was repeated 5 times. And if we have a look at the retention time standard deviation, what we record for all the peaks across the chromatograms is in the range of 0.005 minutes. So in terms of relative numbers, we just say that the majority, more than 50% of the peaks will have an RSD, retention time RSD, between 0.02 and 0.05%. Only a tiny fraction of the peaks sometimes have shows RSD percent above 0.1. So now, if we take a look at details of this chromatogram overlay, and as you can see on the right side of the slide, and we think back to the peak assignment process, where the width of the peak retention time window was important. You see that if I select a peak retention time window of 3 seconds, or even less, 1.3 seconds, I'm sure that I will assign the right name to the right peak. So in this table, we take a look in more details to some of the peaks of the chromatogram on the left, and we take a look at the retention time RSD, which are all very good, and also we take a look at the RSD for the area. You see that all values here are below, well below 1%, 0.6, 0.3, and so forth. We only see one case, which is the peak age, which is above 1%. In this case, is 2.1%, but this is not a chromatography issue. Here we are talking about a very highly hydrophobic peptide eluting late in the chromatograph, and basically during the several hours operation, this peptide was sticking to the vial, most likely, and therefore the solution was depleted from this peptide. So it's not a chromatography issue, it's mostly a sample handling issue. And with this one, I would just go to the following slide, which summarizes what I've been showing you today. We saw in the first part of the presentation how to optimize the resolving power of the peptide separation. Then we dive into how to streamline the peak assignment to have an efficient in comparison of several chromatograms, many chromatograms. And we saw in that part of the presentation how important it is to have a really good retention time precision. We also mentioned the fast separation with the Vanquish horizon, which I didn't show you data on that respect, but I can tell you that also the horizon has a very good retention time reproducibility. In fact, even better than the Vanquish flex quaternary. And with that, I would just pass the word to Kyle for the next poll question.
Thank you, Mauro. So our next poll question asks you, how do you compare your peptide mapping chromatograms? Through visual comparison of a chromatogram overlay, through comparison of retention time and peak area and or height, using both of the above, or through another medium? So we'll just allow a few more seconds for people to respond. Okay, so thank you. It seems like we have about 3/4 responded. So it seems overwhelmingly that everybody uses both of the above techniques, which is encouraging. And Mauro, was that expected?
Yeah, I would say so. Depends a little bit on the analytical lab, or the function of the analytical lab. I see the early development is mostly visual comparison, whereas down the line there is more based on retention time in the peak area. But it is as expected.
Super, thank you. So with that, I'd like to move on to get our customer perspective and pass over to Dr. Amy Farrell from the National Institute of Bioprocess Research and Training. Welcome, Amy.
Right, thank you. Good afternoon, everyone, and thanks, Kyle, for the introduction. So I hope everyone can hear me clearly. If you can't, please let us know. So in the next few slides, I am going to give a snapshot just of some of my experience using the thermoscientific peptide mapping platform. So I'm a member of the Characterization and Comparability Laboratory at NIBERT. And in NIBERT, we provide training solutions and also conduct research in the key areas of bioprocessing to facilitate biopharma companies both in Ireland and throughout the world. And as part of my work in NIBERT, I am involved in the development of analytical methods for characterization of biotherapeutics. And due to its ease of use and to the reproducibility of the data it generates, as Mauro has nicely demonstrated in his slides, the Vanquish UHPLC is fast becoming an intricate part of our product characterization toolbox for a number of reasons. So Mauro and his colleagues have invited me to share some of my experiences, as I said, with the thermoscientific platform for peptide mapping analysis, including sample preparation using the Smart Digest kit, analysis using the Vanquish UHPLC with an acclaimed C18 column, and data acquisition and processing using Chameleon 7.2 and Biopharma Finder software. So I've picked a few aspects of the platform that I have found really impressive and will show some data to highlight this in the following slides. Ultimately, what we found across the different aspects of the platform were beneficial features in terms of reliability and reproducibility of the data generated and the efficiency of many of the platform constituents. The first of these is in regards to Chameleon's software version 7.2. And two really nice components of this software that I particularly like are the use of smart startup, standby and shutdown methods and the availability of e-workflows. The smart startup function saves a lot of time with UHPLC system setup. As for any instrument method, all that is required is to place buffers and a column on the system, initiate the smart startup, and the system does the rest, ensuring that the UHPLC is fully equilibrated before running any samples. And this feature can be combined with your sample queue, so it just really saves a lot of time in the initial startup. I also find the availability of e-workflows very useful, as these are pre-developed methods that may be downloaded from the AppsLab website, it's appslab.thermofisher.com, and directly uploaded onto Chameleon, thereby almost entirely removing the need for method development and optimization in many cases for many different methods that are frequently used in biopharmaceutical analysis. Using the Smart Digest kit, we found a huge time saving for sample preparation through a reduction in digestion time and also in the number of sample preparation steps required when compared to more traditional digest methods, yielding comparable results as I will show on the next slide. And also in terms of the instrument itself, we have found excellent separation efficiency and reproducibility using the Vanquish UHPLC and a Claim 120 C18 column, which again I will show in the next slide or two. So one of the things that we did was to evaluate the incubation times required to digest monoclonal antibodies using the Smart Digest kit. And in the case of the results shown, we digested 100 micrograms of the monoclonal antibody using the kit and using different incubation times, and followed this with a T-step reduction step. Peptides were then separated on an Acclaim C18 column and analysed on a Q-Exactive Plus with the Biopharma option, and data analysis was then performed using Biopharma Finder software. And on the slide, I have shown the light chain sequence of the monoclonal antibody that was digested for 30 minutes, 45, 60, and 75 minutes using the Smart Digest kit. The sequence actually shown on the top right-hand corner corresponds to sample that was digested for 45 minutes. Sorry, that's not a bit clearer. But as you can see from the individual peptides identified, which are shown as little bars across the screen, there were more individual peptides identified using longer digestion times. However, we found 100% sequence coverage with digestion times as low as 30 minutes. The total ion chromatograms shown here correspond to the data shown in the previous slide. And as is a reflection of the different peptides that were produced following digestion using various incubation times and identified using Biopharma Finder, there are some changes in the peaks observed. However, the prominent peptide peaks showed high retention time precision across the different analyses. And this high retention time precision is something we frequently observe with the Vanquish UHPLC. The chromatograms shown in this example were generated following the analysis of a different monoclonal antibody using the same acclaimed C18 column, but this time on a Vanquish coupled to a diode array detector. And again, the separation efficiency and reproducibility in terms of retention time and peak area observed were excellent across different analyses of the protein digest samples. And so just to summarise, from my experience, I know that time is precious in our labs, both in terms of analyst time and instrument time, and I think we would all like to increase our efficiencies, but obviously not to the detriment of data quality. And we have found that optimal efficiency is achievable with this platform by using the smart startup features for instrument setup, using e-workflows for reduction of method development and instrument method preparation time, and also in sample preparation time using the Smart Digest kits for peptide mapping. And that really good data may be acquired with high separation efficiency, high levels of precision, and with full sequence coverage of therapeutic proteins. So thank you everyone for listening to the quick snapshot here of some of our findings, and I'll pass you back to the guys in Thermo.
Thank you very much, Amy. So before I open our Q&A session, I'd like to thank you all for your attention in this second of our 4-part peptide mapping series. I'd also like to thank Dr. Farrell and Dr. Depraz for their excellent presentations. So as you add your questions into the Q&A box, I can see many coming in. I'd also like to welcome Dr. Martin Samanig to the panel, who will help answer some of the questions. Okay, so the first question to the panel is, what is the purpose of using FA or TFA in the mobile phase? Who would like to take that?
Okay, I can take this one. So formic acid or TFA are used as an ion pairing agent. I normally refer as ion pairing agents. And basically what they do is that they ensure that we have sufficient retention and good peak shape for the peptides. Normally, I would strongly recommend not to work without this kind of modifiers. There might be other type of ion pairing agents, but by far the FA and TFA are the most widely used.
Thank you, Mara. The next question is, are there any advantages to adding columns in series?
Okay, so the advantage that you have by adding the column series is that you increase the number of places of your columns. So we know that the number of places is proportional to the column length. So of course, the column vendors cannot pack columns too long for for manufacturing reasons. So a way around would be to couple them. And we can do it by using Viper or nano-Viper capillary, which is a very low dispersion type of connection. And so we are sure that during making the connection we don't lose efficiency, column efficiency. And also the fact that particularly the acclaimed Vanquish C18 is a 1500 bar comparable, we are sure that if we couple them, then we increase the pressure, because we couple them, we don't destroy the column.
Okay, thank you. Next question comes from BioAster. It is, does the Smart Digest kit work well on a complex protein mixture?
Yeah, I can take this one. So the Smart Digest kit was really optimized for mixtures with low complexity, so for monoclonal antibodies, but it also works for complex mixtures, for example, plasma samples.
Thank you, Martin. The next question is, what is Smart Inject and what is the main benefits?
Okay, so Smart Inject is a name of the feature that allows to compress the sample that is withdrawn from the vial and bring it to the same pressure as the column pressure. So as I explained earlier on in the presentation, by doing that, you get rid of this pressure drop you normally have with a normal UHPLC system that do not have this feature. You get rid of this pressure drop after the injection, and therefore you make sure that the flow is not affected by this pressure drop. So, and therefore you make sure that the flow is consistent even during the injection. And the flow consistency eventually will affect the retention time precision, as we saw in the presentation. It's not the only thing that is affecting. Here we saw example of peptide separation, which are gradient, but if you're running isocharotic separation of any other kind, you will notice that if you have a system without sample pre-compression, the first eluting peaks normally lose efficiency and they have a worsened peak shape because of this pressure inconsistency. Well, as we see, we saw data we can share with all the people attending, that we saw that by having this Smart Inject, the peak shape of the first eluting peak is perfect. Is perfect as the rest of the chromatogram.
Okay, and that probably goes on to the next question from the same person. What is a common flow rate used for the acclaimed Vanquish column?
So the acclaimed Vanquish column, in most of the examples you have seen in this presentation, we use the column at 400 microliter per minute. But of course you can use it at other flow rate where you are free to change. At the end we are working with a gradient separation and the impact on the resolving power of the separation of the flow rate is not huge, so you can play around that. And I saw colleagues working at 200 microliter per minute and still getting good results, for example. But the flow rate capability are more important for the high flow rate, for example, 600, 700, 800 microliter per minute. And this is something you need when you do high throughput separation, as we saw an example before. But also, for example, if you run the chromatography at 400 microliter per minute, and then to save time, you run the column equilibration or equilibration and at 600, 700 microliter per minute. This is something you can do, for example.
Thank you. Next question is, you mentioned the ultra-fast data acquisition of the Q-Exactive HF. How fast is it?
Yeah, I can take this one. So the actual scan speed of the Orbitrap mass analyzer depends on the selected resolution. But with a resolution setting of 15,000 at M/Z200, you can reach scan speeds up to 18 Hertz.
Okay. We have another question, again from BioAsta. What is the best digestion time to use for plasma samples using the Smart Digest kit?
Yeah, so we recommend for IgG in plasma digestion times of 75 minutes.
Okay. Just got some more questions coming in now. Oh, here's an interesting one. What are the advantages of Vanquish Horizon versus Vanquish Flex?
Okay. So the Vanquish Flex is our system of choice for method development and biopharma and other type of analysis. The Vanquish Horizon is our high-end system. The advantages of the Vanquish Horizon, the clear one was the pressure capability that you have seen. You have seen in the previous slide. Is not the only advantage we have. There are also other important features. The fact that the system has a very low gradient delay volume makes it highly suitable for high throughput separation, particularly on CMS platforms. There are more features. The binary pump is a dual piston dry pump that delivers really unsurpassed accurate and precise flow. So the data in retention time precision we are seeing in this presentation are for the Vanquish Flex. The data you would see, and I didn't show today, for the Vanquish Horizon are even better than this. And there are also other features that makes the system very interesting. I mean, for example, just to mention one, the Vanquish Horizon has a automated purge capability, so it means that it can be purged remotely, so you don't have to be in the lab to run the purge. So that this is also an interesting feature in case you need to change solvent and you're not in the laboratory and so forth. And many other features that, for the sake of time, I will not go through now, but we'll be happy to share with any interested person.
Super, thank you. So, one last final question from Algorithm Farmer. What is the difference in scan rate of the Q-Exactive HF compared to the Orbitrap XL?
Yeah, I can take this one. So the Orbitrap XL is a very already quite old instrument. So the first Orbitrap instrument, more or less. So and the difference in scan speed is more than factor 10. So the Q-Exactive HF is more than 10 times faster compared to the Orbitrap.
Super. Thank you. So I'd like to thank everybody for their great questions, and there's been a huge amount of engagement. And I'd just like to ask you if you could all maybe consider completing the survey before you leave. It really helps us to improve the content that we can bring you in the future. So with that, I'd like to close the presentation and the Q&A session, and thank you and welcome you at our next peptide mapping webinar.